Calculate, correct to one decimal place, the area of PQTRS. PQTRS is comprised of two basic polygons. One rectangle, and two right-angled triangles. The area of a rectangle equals the length times the breadth, so the area of PQRS equals 9.4 times 3.5, which equals 32.9 square units. The area of a right-angled triangle equals half the base times the perpendicular height. We therefore need to determine the length of both TM and QM, which are the height and base of triangle QTM respectively. Since triangle QTM is right-angled, to determine the length of these two sides, we will use trigonometric ratios. Relative to the angle 32 degrees, TM is the opposite side, and QT is the hypotenuse. Therefore, TM over QT equals sine 32. TM is therefore approximately 4 units in length. Similarly, relative to the angle 32 degrees, QM is the adjacent side, so QM over QT equals cos 32, which means that QM is approximately 6.4 units in length. The area of triangle QTM is therefore approximately 12.8 square units. As PQRS is a rectangle, the length of QR is 9.4 units, since opposite sides of a rectangle are equal. We can therefore deduce that the length of MR, which is a side of triangle TMR, is 3 units in length. The area of triangle TMR is therefore 6 square units. The area of triangle QTR is thus the sum of the areas of these two right-angled triangles, which is 18.8 square units. The area of PQTRS is therefore the sum of these three areas, which equals 51.7 square units. There is an easier way to determine the area of triangle QTR, and that is by using the area rule. The area of triangle QTR equals a half QR times QT, sine 32, which equals approximately 18.7 square units. The difference between the two answers is due to the rounding of decimals. If you are unsure about anything we have just done, or just want to refresh your memory, these concepts are covered in detail in the workbook, and in the online courses, the links of which have been provided in the description box below. The vertical wall of a building stands on a horizontal plane. At G, against the wall, a flagstaff FG is affixed to the wall, such that it forms an angle Z with the horizontal. At B, the angle of elevation of G and F are X and Y respectively. BL equals A units in length. We are required to prove that FG equals A sine Y minus X, all over, cos X, sine Y plus Z. Before starting the problem, it is a good idea to find all the required angles. In other words, find the angle Y minus X, and the angle Y plus Z. The angle Y minus X is the angle FBG, which we can deduce from the given angles, Y and X, which are the angles, FBL and GBL respectively. Next, notice that BGM equals X degrees, as alternate angles are equal. MG and BL are both horizontal lines, which means they are parallel, and thus we know that we have equal alternate angles. In triangle FBG, angle F plus Y minus X plus Z, equals 180 degrees, since the interior angles of a triangle are supplementary. Angle F therefore equals 180 minus Y plus Z. We will leave it in this form, since we are specifically looking for the angle, Y plus Z. Now that we have found the two required angles, we can begin the problem. The problem includes the side BL, which equals A units in length. We will therefore start in triangle BGL. Since this triangle is right-angled, we will use a trigonometric ratio to relate the angle X to the side A and side BG. A over BG equals cos X, which means that BG equals A over cos X. In triangle FBG, we now have the two required angles in one side, and we are looking to find another side, FG. We can therefore use the sine rule. Thus, FG over sine Y minus X equals BG over sine 180 minus Y plus Z. FG therefore equals BG sine Y minus X, all over, sine Y plus Z. We now have two expressions involving the side, BG, so we can substitute BG equals A over cos X into the expression for FG. FG therefore equals A sine Y minus X, all over, cos X sine Y plus Z, which is what we were required to prove. If you like this video, subscribe below, hit the like button, and leave a comment to let us know what else you'd like to see. Thanks for watching.